Okay, in this video, I want to talk a little bit about the method that we're going to use to measure how much product we get from our reaction. So you remember that in the previous video, I talked about the fact that we can determine what the coefficient is if we can find out at what point do we generate the most amount of product. In order to do that, notice that if I don't know the coefficient, I have to actually measure how much product I make to get these numbers. Now, how are we going to measure how much product we're going to make? Well, it turns out that we can do this with something called absorption spectroscopy. And the idea of absorption spectroscopy is the following. Whenever you see something that has a certain color, let's say you look at this number here and it has a red color, what that means is that it basically has white light shine on it and it absorbs everything except for red. In other words, it absorbs the blue component of the white light, it absorbs the yellow component, the orange, etc. And the only thing that it's reflecting is the red. Okay, so every object does this. It absorbs some amount of light that is shine on it. So we're going to use this to help us figure out how much product we're going to have. But how? Well, remember, one of the things I mentioned about the reaction we're going to be doing today, which is the complex ion formation reaction, is that these complex ions have color. The reason they have color is because they absorb some type of light that is shine on them. Okay? Now this is important because as it happens, the intensity of that color is correlated with how much complex ion you have. So if you have a lot of complex ion, then the intensity of that solution will be very, very dark. Whereas if you don't have a lot of the complex ion, then the intensity would be lighter. This is something that has been formulated into an equation called Beer's law, where the amount of light absorbed, which is shown here at the symbol Abs, is equal to a couple of constants times the concentration of the sample or the molecules in the sample. So the idea is the following. If I put my sample in a container that looks like this, I shine light on it. When I shine that light over it, what happens is the light that comes out on the other side is going to be less intense compared to the light that goes in. The reason is because the sample has absorbed some of that light. I can calculate the absorbance of that sample by taking the difference between the light that goes in versus the light that goes out. This is done automatically for you, so you don't actually have to do this calculation. But it turns out that that absorbance can be related to the concentration of the sample in here. So if it absorbs a lot of light, that means the sample is very concentrated. If it absorbs a little light, that means the sample is not very concentrated. Now, the measurement that we're going to do is going to be carried out in something called a spectrophotometer. And this is a schematic of a spectrophotometer. It's basically an instrument that has a light source inside it, and you turn on that light source, and there is a little prism in there that sort of focuses that light source to a specific range of wavelength. And then when that light is shined on your sample, as I said just now, some of that light is going to be absorbed, and then the spectrophotometer will basically calculate for you how much light is absorbed. And you're going to see a display. For example, here it's showing 0.2. That means that 0.2 absorbance unit of light is absorbed. Now, let's say you see another sample, you put in another sample, and then it shows 0.4. That means that second sample absorbs more light than the first sample. So here's the actual spectrophotometer that you would be using. It's called Spectronic 20 or Spec 20. And it looks like this. And this is called the sample compartment. That's where you're going to put your sample in. Now your sample can't just go in a regular test tube. It actually has to be placed in a special type of test tube called a cuvette, where the glass is a little thinner, a little more transparent to light, so it doesn't actually absorb light on its own. Now you want to make sure when you're handling this cuvette that you don't leave hand marks or any kind of marks on the glass. So if you want to clean it up, make sure you use something called a Kim wipe, because if you use paper towel, it will actually scratch the glass and then that would affect your measurement. So what you're going to do is put your sample in the cuvette and then afterwards put the cuvette in that sample holder that I was showing you earlier. Now just keep in mind that you only need to fill the cuvette up between half to 3/4 full in order for your measurement to be read correctly by the spectrophotometer. Now let's go back to the spec itself to explain the operation. The first thing that you want to do is make sure you turn on this knob on the left all the way to the max. that controls the amount of light that the spec generates. So you want the maximum amount of light you can get because you want the most signal you can get. And then afterwards, you're going to put a sample in here that initially it's not the complex ion, but just the iron. Okay, so let me repeat that again. You just want to put the iron in there at the beginning, and you're going to do something called zeroing or blanking the spectrophotometer. And that's basically the same as tearing a balance when you set the balance equals to 0. Okay, so we're going to do the same here with the spectrophotometer. We're going to set it to 0 at the appropriate level. So we put our iron solution in there inside the cuvette. We close the sample compartment, and then you're going to do two things. You're going to turn this particular knob to adjust the wavelength. You're going to be able to see the wavelength shown here. So if the lab manual asks you to go to wavelength 500, you're going to adjust this until you see the number 500 showing up there. Okay, then the next thing is you need to adjust the absorbance so it's 0, because remember, this is the same as tearing the balance, so you want to make sure that that number goes to 0. Before you can get to adjusting that number to 0, first you have to change the mode of the spectrophotometer so it measures absorbance. So you press this mode button so it toggles from the top to the second one. Now you're in absorbance. Then you start turning this knob. You might turn it clockwise or counterclockwise. It just depends on where you're at, but you want to get to 0. Once you get to 0, or like in this case 0.001, you're close enough and you're good to go. At that point, you can take out your blank solution and put in another cuvette with your actual sample solution and just read here to see what the absorbance is of your sample. And that's how we're going to determine how much product we have in each of the mixture that you're going to make in the lab.